On to question 24 of the AMC. In trapezoid ABCD, angles B and C measure 60 degrees and AB equals DC. The side lengths are all positive integers and the perimeter of ABCD is 30 units. How many non-congruent trapezoids satisfy all these conditions? The trick for these kind of questions is just to label whatever you can, right? So firstly, when I see this, I see 60, first thing I always do is just draw lines here and create right angles. You're right and you're 30. Okay, and same thing for the right triangle. Now, let's just say I label this top bit A, and I label this entire bottom side B, right? Then, this bit, this small bit over here, that is the difference. If you do B minus A divided by 2, that's going to give us this bit, right? So if I just draw it over here, that bit is equal to B minus A divided by 2. Okay. And a cool thing to know about 30, 60, 90 triangles, if I just draw one here, right, and that's 90, that's 60, and that's 30, it's half of an equilateral triangle. If I just complete it, that's also 30, that's 60, and that's 90. Basically, if this, so I'm just going to erase this bit. Basically, if this side is x, this side is always 2x, and this side is always x root 3, no matter what the triangle is. So if we know that's b minus a over 2, this bit, then this bit is going to be b minus a over 2 times 2, which is just equal to b minus a. And if this side is b minus a, this side must also be b minus a. So now we get this really cool thing where a plus b minus a plus b minus a is equal to 30. So if I write that out, actually I'm just going to type it. I don't want to write it. So a plus b minus a plus b minus a is equal to 30. And if I want to simplify it, that becomes a minus a minus a, and then that's b plus b is 2b plus b, so that becomes 3b minus a is equal to 30. Now I can just do trial and error and see how many conditions, how many possible values of a and b satisfy this equation, right? So if I say b is equal to 10, then a must be 0, which is not possible because a has a value. A has to be the top bit. A cannot be 0. So if I say b is equal to 11, then a must be 3, right? And I can just keep going until it doesn't work. If b is equal to 12, then a is equal to 6. That also works, so these two work. Then if b is equal to 13, then that means that a must be equal to 9. That also works. If b, no space, I'm going to write up here. If b is equal to 14, that means that a is equal to 12. That also works. And if b is equal to 15, then that means that a is equal to 15 too, and that will not work. Why? Because clearly b is a lot bigger than a, and a and b cannot be the same thing. So how many ticks do we have here? 1, 2, 3, 4. We have 4 possible solutions for a and b. So the answer is E, 4.